So now that we understood lines and line segments, let's try to define what is array. So as we know, for line segment I have 2 points A and B. It's just a line segment. But if I extend this line segment either one of those sides, either on the right or on the left, so let me just try that, or on the left, this is called as ray. Endlessly, so again it's endlessly, so in the sense I can extend it as long as I wish. So that's array. Now what is an angle? Angle is a figure formed by two rays, but there are both rays are starting from the same point or the vertex. So if this is the point, and if this is one ray and another ray is somewhere here, that is called as angle. Angle made by two rays, that's a ray, that's a ray. If I'm going to put this as A, B and O, so OA is a ray, OB is a ray, represented as like that, just exactly how you write ray. So angle is a figure formed by two rays with the same point, initial point. So in the sense they both are originating from the same point, so that's the same point, that's a point. Or otherwise sometimes it's also referred as vertex. Remember, vertex is singular, that is singular, and vertices is plural. So a triangle or any other shape might have more than one vertex, so they're all called as vertices. So here the point or one vertex, starting from a point or from one vertex, two rays are drawn and they make an angle in between them, so that's an angle. Now let's start talking about adjacent angles. If I take a ray and another ray, we said that these two are making an angle here. So condition for adjacent angle, adjacent, what does it mean? Adjacent is next to each other. I cannot, if for example if I mention someone that adjacent to my house is a house which is next to your house, not a house in some other area, so that's not adjacent, it's in some other area. So adjacent to your house is next to your house, not the opposite, again entirely different meaning. So adjacent is next to you. So here adjacent to this is just next to this, one more ray. So what happened here? What do we see here? So let's just put some points just for the sake of reference. So adjacent to this ray I've drawn another one. This ray becomes a common ray or common arm, ray or common arm. These two rays are opposite side of this ray. So OB is the main ray, is the common, and OA and OC are opposite sides, opposite rays or arms of OB. They are on opposite sides. So let's take, if I just take another example, just like that, O, A, B, C. So can I call OA as common or no? Because on one of the sides I can see OB, on the other side, this side, I don't have any ray here. So OA will never become a common arm, common ray. So in this case OB is the common. OB is the common. So that means OB is the common, opposite rays are OA and OC, these two angles. The common arm and other two rays are opposite sides of this common arm, and the angles made by those, this and this, they are called adjacent angles. Adjacent angles. So let's say, for example, if I take this O A B, an angle, and another angle C D, I don't know, something else, can these two angles be adjacent? No, they are supposed to originate from the same point. Another thing is, they are supposed to originate from the same point. Some of the conditions of adjacent angles are, they have to have a common vertex, one just originating point. They have common arm. Which is the common arm here? Here OB is the common arm. In this, OB is the common arm. So there is a common arm, and the other arms are opposite sides of the common arm. Just as I explained, OC and OA are opposite sides of common arm. This and this, these two. So that's the only time you will call those angles next to each other as adjacent angles. There are so many examples. You might encounter so many things in different standards, but let's just see. If I take a rectangle or a parallelogram, anything, what are the adjacent angles here? This and this are adjacent angles. Angle 1 and angle 2 are adjacent angles. Similarly, angle 3, angle 4 are adjacent angles. So these are the only adjacent angles I can see, because that is my originating point. This is the common arm, these are the opposite arms. Understand this, because suddenly when you use this concept even for proving anything, just not with the angle values, but even to prove that adjacent angles, yes, you need to make sure that what are adjacent angles, which are the adjacent angles you are going to represent in your diagram. So next, moving on to vertically opposite angles. So we know that two line segments or two lines intersect at a point. So that was my point of intersection. Point of intersection. So when do we call, how do you find out vertically opposite angles? The angles which are formed by two intersecting lines having this no common arm. So what does that mean? So if I take an angle, what did I say? This is an angle. There are no common arms here. OA is a different arm, OB is a different arm, two different rays. So if I come back to this example, no common arm. So if I am mentioning, let's just take this as ABCD, so it will be easy for us to represent. O is the point of intersection. So if I now mention angles, angle AOD, how do we write angle AOD? That sign and then AOD, or any angles, BOD, angle COB, angle AOC. So these are the four angles. That's first angle, second angle, third angle, fourth angle, four angles. So what are vertically opposite angles? Angles made by intersecting lines with no common arms. So if I take angle 2, which is BOD, that is 2, and opposite to that is 4, AOC, that is 4. These two are vertically opposite angles. Similarly, these two are vertically opposite angles. In both the cases, AOD has AO and OD, and BOC has BO and OC. No common arms are there. No common arms are there for those angles, whichever angles which I have mentioned here. So no common arms, and the opposite angles are called as vertically opposite angles. Let's understand one more, because I didn't want to include this in this section, but still it will be a very important concept. Angle bisector. You use this in lots and lots of chapters. So let's say if I take an angle, so any angle A, B, O. Let's say this is my angle. Angle bisector. If I say, let's say there is another ray OC. So we know that these two are adjacent angles. These two are adjacent angles in the sense angle AOC and angle BOC are adjacent angles. But when the condition is given as OC is the bisector, what does that mean? Is the bisector. What does that mean? It means angle AOB, entire angle AOB is bisected by that arm OC or the ray. So in the sense, if my angle AOB is 60 degrees, if OC bisects angle AOB, what will happen? Angle AOC should be equals to angle BOC should be equals to 60 divided by 2, which is 30. So both of them 30. So bisector, it is bisecting in half. So remember that, bisecting in half. So AOB, the total angle, if total angle was 60, if this was 60, if this entire thing was 60, this will be 30, that will be 30. So angle bisector, whenever they use angle bisector, they might either give you with the value of the angle itself, or otherwise they'll just mention if there is a ray or some other line segment or the diagonal of some figure or some line segment or line is bisecting an angle. What does it mean is, if there might not be no values, but it means AOC is equals to BOC. So AOB is divided into two same values of angles. So that's angle bisector.